Hey y'all. The Okay, so let's get started. And the big thing we need to talk about, we have an exam coming up next week on Tuesday. It's online on Canvas. It's open note, open book. I am going to try to, so we're going to be using the Respondus Lockdown browser, and according to the directions, it should be possible for me to put whitelisted links to both the Zybook and to the Oracle APIs. We are going to test that on Thursday. So on Thursday, there's going to be, I've put together a very simple practice quiz. All it has you do actually is copy a class declaration that I have so that you get to use the pre-formatted text in the essay question so that you get nicely formatted code. Supposedly, with using the Respondus Lockdown browser, they now have a beta feature that allows a Zoom session to be in the background so that you can ask questions. So we're going to test all of this on Thursday. So please download the browser before then. And what will happen on Thursday is that we will meet here. Then I'll give you the quiz directions, and you will then try to open the lockdown browser to take the quiz, and hopefully all will go well. We'll have you test to see whether you're able to get through to the Zybook and to the Oracle docs. So that will all be at the beginning of class on Thursday. As for the exam itself, I know we've covered a lot of material. For coding questions, you're going to only be responsible for writing Java programs. I expect you to be able to trace or read and trace any C, C++, or Java code that I give you and answer matching, fill in the blank, multiple choice, multiple answer questions about C and C++ features for inheritance, modules, exception handling, and generics. The exam is 85 minutes. So what I did is it will start at 1:10, but it will go through 2:35. So you'll get 10 minutes past the scheduled end of class. And I have posted a review guide and the sample exam on the Course 365 website. So if you go to the course website and you go to sample exam, so here's the review guide right here. Here's the sample exams, midterm and solutions. We're covering everything up through Thursday on the exam, which is widgets and message dialogues for graphical user interfaces. And I guarantee you there is such a question on the exam. So what we covered today and Thursday, there is a question on the exam about it. So any questions thus far? Any questions that anyone has?
Will we be required to join the Zoom call?
You will probably yes, because go ahead.
So that is very distracting for me if someone asks a question while I'm in the middle of a test.
Okay, if you don't join the Zoom call, you will be unable to answer the question, to ask a question.
Okay. Could I feasibly join to ask a question? Should I have one and then leave?
Well,
I suppose
issue, okay, let me think about it. The issue is that I was going to use the Zoom also to do monitoring. So it seems like if I do a Zoom session, then I don't have to do I can have you all do a video camera through Zoom, and then I don't have to use the Respondus monitor. So actually, having the Zoom session was pretty important.
Someone
I
said in
thought there
chat,
was
I
a
could
way that you
simply,
could mute out everyone in a Zoom.
yeah, someone in chat has already suggested that. That solves my issue entirely.
Okay.
And also, since I'm afforded extra time for tests, will I be given that as well?
Yes.
Okay.
So, do you have time past? Can you slot into the next class period?
Oh yeah, I'm fine. Yeah,
Okay.
I can take it at that time.
Okay, perfect. Okay. Other questions?
Do you know how many questions are going to be on the exam?
There are 6 questions. There are 3 coding questions, couple fill in the blank / matching questions, and one that's kind of a half coding question. I can't give away what it is, so, but it evenly covers all the material that we have covered. Basically, there's a question on inheritance, there's a question on exception handling, a question on Java basics, there's a question on generics, question on packages, question on GUIs, and then a question on just general stuff that we've covered. Other questions? Okay, I will highly recommend these sample exams because I actually did choose one that is pretty consistent with what I did for this one's pretty on the numbers, are pretty close in style to what the exam looks like. The only thing is with inheritance, there won't be any drawing because there's no way to upload a file. So the inheritance will involve doing class declarations. Other questions? Okay. In that case, a reminder, I did push the quiz deadline for exception handling back. So it's due Thursday. So you're actually going to have 2 quizzes due Thursday. The one for exception handling that we're finishing up today, and then the one for GUIs that we're starting today. So you actually have 2 quizzes due Thursday. So just keep that in mind. And today we are finishing up exception handling, specifically with Java. We're going over Java exception handling, and then we're going to start into graphical user interfaces. So I'm only going to talk about how Java differs from C++ because it and basically Java took C++'s handling and they tweaked it. So they used the same try-catch construct that C++ uses. The difference is, as with all things, Java is very class-oriented. So it has an actual top-level exception object. Actually, that is like C++. C++ has std : exception. Java has a top-level throwable class, and it has some useful methods associated with it. One is print stack trace. By now, you have all seen a stack trace when your program has ended early. Java prints the stack frames and where in each function which line was executing when the exception occurred. It also prints the error message. So that's what print stack trace does. Then all of them also have a get message, which returns a message describing the exception. So then below throwable, Java has two predefined classes, one called error and one called exception. So the error one is errors that are not recoverable. So you are not expected to catch them. Instead, they're basically thrown to the top level and Java prints out a stack trace and an error message. So that includes things like out of memory errors. That would be the most common one that would not be caught. If there was an error in the virtual machine for some reason, that would be another error that was thrown. So recoverable errors are exceptions. So these are recoverable. And Java provides two predefined descendants called IO exception, which you are familiar with from using scanners and file IO. They also have runtime exception. And this covers things like array index out of bounds or no pointer exceptions. So you can recover from them if you want. And then this is what you should subclass. So user defined or declared exceptions are supposed to subclass exceptions. So when you create your own exceptions, you should be subclassing the exception class. At least that is the expectation, that you will subclass the exception class. Okay. Unlike, okay, so then as far as the catching of things, everything is the same. So it's the same try, catch idiom. The only difference is that the parameter now, it's a single parameter, but that parameter requires a must be named, unlike in or I'm going to say exception type, unlike in C++ where you don't have to include the parameter name. In Java, the parameter name is required. So it's required in Java. The other one was that in C++, you could say catch ... and that would catch any exception not already caught. ... doesn't exist in Java, but you can instead catch an exception, and that should have the same effect because you're only supposed to catch exceptions. Therefore, your final catch clause, if you put catch exception E, it should catch any exception that has not already been caught. One thing I did not cover last class, or I kind of glossed over it, is the order of catch statements is important. So order matters because both C++ and Java search the catch statements sequentially for the one that matches the exception. So for example, let's say you have a class, well, in Java, you have class foo exception. Extends exception. And you have goo exception extends foo exception. So basically, a goo exception is a more refined version of a foo exception, And a foo exception is a more refined version of an exception. So if you have try and catch for these, the order of the catch statements should be catch the goo exception first, then the next catch should be the foo exception, and the final catch should be exception. That should be the order. And the reason is, again, both Java and C++ do a linear search starting from the first one. So if I throw a goo exception, new goo exception in Java, I probably want this exception handler to handle it because it's the most specialized for a goo exception. If I reverse this sequence, so let's say that instead of this being first, let's say that I put this catch statement first. So let's say that the ordering, I changed the order so that the order is this one was first, this was second, and this was third. Then when I threw the new goo exception, because this one was first, this one would catch it and handle the exception. And only one catch block handles the exception. Only one catch block in a catch list handles an exception. If you do a rethrow, so you are allowed to do a rethrow. So you might think, oh, if I rethrow E out of this exception, then it will continue to search this catch list. That's false. Throw throws out of this try statement and throws to the next enclosing try statement. So only one catch statement will be executed, and therefore you want to have them go from the most specific to the most general. So catch statements should be ordered from most specific to most general. From the most specific exception to the most general exception. Does that make sense, what I'm saying?
Yes.
Okay. That is good.
I have a question.
Yes.
Suppose you catch a throwable. Could you just bypass Stack Overflow if you caught a throwable?
If you catch a throwable, yes, you would end up catching, for example, Stack Overflow, and that would be bad.
That seems bad, yeah.
Because you can't do anything with it. You can't recover from it. So the answer is yes, don't do it.
You could design malicious programs, yeah.
Yeah. Okay. So, other questions? Yeah, so this is kind of would fall under like the stupid pet videos. Don't do it. Okay. So exception binding is the same as in C++. So if you throw a subtype like here, goo exception, it matches a foo exception and exception. So it matches any super type. The continuation is the same. So if the catch block finishes, then execution picks up after the try block, with the first statement after the try block. A couple differences is in Java, all Java exceptions are thrown off the heap. Using new. So this is unlike C++. Remember in C++, I said do not use new, throw stack allocated objects so that the C++ runtime system will automatically deallocate it. But in Java, there are no stack allocated objects, so Java exception objects have to be thrown off the heap, and they'll be automatically garbage collected. Also, when you rethrow in Java, must include the exception object, unlike in C++ where you just say throw. So in Java, if you have a catch statement, and at the very end you want to do a rethrow, you have to give the name of the exception object. And again, that will throw out of this try statement and up to the next enclosing try statement. Okay, the next change in Java is you have to, if you don't handle an exception that you throw, then you have to declare in the method header that you don't handle it. So for example, if I have, so I have to declare unhandled exceptions in the method header. So you've already seen this with IO exception, where you sometimes have had a method like, say, void foo, and it doesn't handle the IO exception, so you write throws IO exception to indicate that you are not planning to handle it. It is up to the calling function to handle this exception. So you have to declare both explicitly thrown exceptions, meaning ones that you explicitly throw, and implicitly thrown exceptions that are called by methods you call. So you must declare both explicitly thrown exceptions and implicitly thrown exceptions. Okay, so a explicitly thrown exception is one where you actually throw it. So saying throw new, say foo exception, that's an explicit throw. Whereas doing like an open, and I forget, something like A equals new, say file reader. That could cause a file not found exception. That would be an implicitly thrown exception. You have to handle that one as well. And Java type checks all exceptions. So Java type checks any exception. So it doesn't type check errors. Remember, there's two types of exceptions. So it type checks any subtype of that extends exception, except for runtime exceptions. It does not type check runtime exceptions, and you don't have to catch them. So for example, you do not have to explicitly throw, you don't have to, if you don't handle a null pointer exception, you don't have to say void foo throws a null pointer exception. So you only have to declare in the method body IO exceptions and any user declared exceptions that extend the exception class. So you don't catch errors, and runtime exceptions, you don't have to catch them, and you don't have to declare that you don't catch them. Questions about that? Okay. So then the fourth difference with Java is it does have something called a finally clause where you execute code. It's put after the catch statements. And it always executes. And it always executes, which means if the try succeeds, it executes. If the try fails and the exception is not caught, it executes. And it executes if the try fails and the exception is caught. So no matter what, the finally block executes. It executes after all other processing has completed. So for example, you might do it with, typically when you have to close resources, like if you open a scanner, you need to close the scanner. If you open a file, you need to close the files. Things that need to happen no matter what. Typically, this is typically used to close resources or release resources. Okay, so here's an example of a finally statement. So I have a public void execute throws my exception. You see it does a try, and all it does is it throws new my exception. Then it doesn't catch it, but it has a finally clause that prints out leaving execute. Then in main, that's where I catch my exception. And you see I print my exception in main. And so what happens is when I execute this code, I start by creating an instance of new temp, which calls the constructor, and you can see the constructor does nothing. Then inside the try statement, I call execute. Execute immediately throws new my exception. It's not caught, but the finally clause is executed nonetheless. So the first output from my program is leaving execute via finally. Then I throw out of this execute and I catch here in main. So it prints out caught my exception in main, which is what you get here. And with the catch completed, execution continues after the try statement, thus printing out leaving main. So your output looks like that. Okay, so no matter what, the finally statement gets executed. If there was, so let's just do some, let's copy this to a file. I think I called it temp.java. Okay, let's make this actually an internal class of temp. And we'll compile it. Did not like it. Public class temp. I didn't compile it. So I run it, and it's just what I said. So what I'm going to do now is show you, let's do an if statement. If false, throw my exception. So of course it doesn't get thrown. And just for grins, we'll say system.out.println leaving the try. So in this case, this exception will not get thrown because this is trivially false. So we'll execute this print line leaving try. Then the finally clause will still get executed. So we'll have leaving execute via finally. This time there will be no catch of an exception because the exception wasn't thrown. So we'll just print out leaving main. Okay, at least that's what I claim. And there it is, leaving try, leaving execute via the finally, leaving main. So finally gets executed no matter what. Now, remember I said normally you use finally to release resources, and it's very easy to forget to release the resource. So Java introduced what was called a try with resource. So before the beginning of the block, you're allowed to declare resources. For example, I could say try, say scanner buffer equals new scanner console dot next line. This is called a try with resources, and what it will do is obviate the need for a finally clause because it will automatically close the scanner when the try finishes. So no matter whether the try finishes normally or not normally, the scanner will get closed. So this is a good alternative to using the finally clauses, to simply use this so-called try with resources. And again, you just in parentheses have the resources that you want to try to acquire before the try block. So questions about that?
Do scanners kind of function like heap allocated objects where
Yes.
if we reach the end of execution, the operating system is going to claim back those resources regardless?
Yes. But the problem is,
Okay.
as long as they're open and have not been closed, they can't be garbage collected.
Okay.
That's
So
why I
if you have
always
something
emphasize that it's important to close a scanner once you have finished using it, because if you don't, the space essentially becomes a memory leak.
Okay, thank you.
You're welcome. And that's true of everything. Files, any resource you allocate, if you fail to release it, it won't be garbage collected. And that's one of the biggest sources of running out of memory errors in long-running Java programs, is the failure to essentially close resources like scanners and files. Other questions? Okay. With that, I actually don't have a lot of time to go over it. I will say one thing about, I'm going to go back to C++ for one moment. Up to now in C++, you've been accustomed to, if an error occurs and you want to exit, let's say you have main, and main is called A, and A calls B, and B calls C, and something happens in C that causes you to want to exit the program. And up to now, generally, it's been okay to just call exit at this point, and that exits the program in C. This, however, is not considered to be good form. Normally, you should only exit a C++ program in main. And the reason is that when you exit here, it does not call destructors, are not called for variables in main A or B. And if they acquired resources, it's possible the resources aren't released, or aren't released in the way you expect. For example, the most common thing is you opened a file for writing and you exit, and now it's up to the operating system how it handles that file that you opened for writing. You would probably be much happier if you had explicit control over what happened to that file. So it is generally considered better, instead of calling exit directly from C, it's generally considered better to actually throw some exception and then catch it in main. And that way, all of the variables in actually B, A, and main have an opportunity to have their destructors called, and then you can exit the program. So in general, the general principle in C++ is you're only supposed to exit from main. So you're only supposed to exit from main. And I know it's not a big thing, but it's just something you should get in the habit of doing, that you actually, if you want to exit, if you encounter some error condition that should terminate the program, but you're in a deeply nested function, you should actually throw an exception that you catch in main and then exit out of main. And that way the destructors in the intermediate stack frames get called and resources get disposed of properly. Okay? Any questions about that? Okay. In that case, we have just finished the first chunk of the course. So as I've said, the first chunk of the course was devoted to introducing you to Java and some of the advanced language features associated with Java, such as generics, exception handling, inheritance, and packages. And we also explored how those mechanisms were handled in C and C++. So this course is called an overview of programming languages and systems. So we've overviewed Java and some of the more advanced features of programming language systems. What we're now going to move into for the rest of the semester is 4 different types of programming than what you're used to. So you're used to imperative programming. So you're used to essentially what you've been exposed to is a paradigm called imperative, which is also often called procedural programming. In the rest of this semester, you're going to be introduced to 4 new paradigms: event-based programming, which is graphical user interfaces, or is actually simulations, and GUIs are both examples of event-based programming. We will cover scripting languages, and specifically we will cover Python. Then we will cover concurrency, and we will cover that in the context of Java. But concurrency is multiple executing threads that cooperate. So it's more a bit like concurrent parallel programming. And finally, we will look at functional languages. And we'll be looking at Scheme, which is a Lisp variant. On each of these, we will spend roughly 2 weeks. So today, we start into event-based programming. And the basic premise, let me actually gather my notes. So event-based programming means that the input, essentially input, so in event-based programming, input arrives via events rather than the console or a file. And depending on the type of application, the events may differ. So in a GUI, in a graphical user interface, which is what we will be focusing on, the events will typically come from the mouse or the keyboard. Okay, if it's an iPhone, it could be from voice recognition, a voice event. So in a simulation, that can be, if you're running a physics simulation, there just may be events generated by the simulation. So events such as a clock, or events come from things like come from a clock or other objects. And unlike a procedural program, in event-based programming, the user, you have to respond to events immediately. So in a procedural program, you're in control. You say, I will take input when I'm ready for it. In an event-based program, the user says, hey, I have an event, it's happening now, you have to deal with it now. So there are differences. So the difference is, so you have external, what we call external versus internal control. So in a procedural program, you have internal control. You control when you take input. In a event-driven program, it's external control. The user decides when you will get input, and you must immediately respond to it. So external events require an immediate response. You drop everything and respond to it. In some sense, you are reactive in an event-driven program. You have to immediately react to events, whereas in a procedural program, you're proactive. You say when I want input. When I'm ready for input, I will take input. In an event-driven program, input can arrive at any time and you have to respond to it immediately. Second difference is you have what is called distributed versus central control. So in a procedural program, you have a single thread of control. It starts in main. Main can call a function, but at any given time, there's only one thing, quote, executing. Whereas in a event-driven program, you can have multiple things logically executing at the same time. So if I have a simulation, I might have multiple, let's say I'm showing trucks running through delivering product. I would have multiple trucks running at the same time. Each truck would be its own locus of control. In a planetary simulation, each planet moving would be distributed control. In a graphical user interface, you might have multiple animations going on at the same time. So there's not one locus of control in a event-driven program the way that there is in a procedural program. In event-driven programs, you can think of things as often being objects, and each object having some control that it may be executing logic simultaneously with other objects. And finally, you have event-driven processes working cooperatively versus in a procedural program, centralized authority. So a good example of that is this notebook I'm using. If I take this pen and I move it over here to the eraser, I've just changed the mode from drawing to erasing. So now when I go up here, erasure occurs. So that is two independent processes cooperating. Up here, there's what I'm doing in the drawing editor, which was affected by what I did here, which was to select the eraser. Now I'm going to select the pen, and back up here, I'm using a pen again. So these are two different things. Down here, this is a palette of options. I know it's hard to see. Here's another palette of options. So I can select these options, and they, in effect, each of them is an independent process, but they affect what occurs here in the main window. Okay, and at any given time, I can push any of these buttons. I can do something here in the main window. I can actually select from one of these menus. So I can do one of many different things at any one time in an event-driven program. And the underlying program has to be able to deal with any action I take. So that's what's meant by distributed control. I can take any action I want, whereas with the centralized authority and central control, it is up to the program what it does next, and it's in control. So this is something that's very hard to get used to with event-driven programming, and it's why we expose you to it here in 365. So we will be talking, as I said, about graphical user interfaces. And probably the best way to start is to introduce you to a program. So we have a very simple Hello World program that I'm going to walk you through. Just going to show you what it does. You can see here, all it does is it's popping up a window with north, west, south, east, and in the middle, the words Hello World. So very simple graphical interface. And you'll see if I press with the mouse, it goes to By World. I can press on any of these labels, and you can see when I press on them, how it's toggling between By World and Hello World. So I am generating events by clicking and by moving the mouse. And as I do that, in response, it's toggling between Hello World and By World. So the first thing is there's a presentation component to every graphical user interface, which is what is presented or displayed in a window. And there's a behavioral component, which is what that program does in response to events. In this case, it's toggling between By World and Hello World. Okay, so let's take a look at that program. So first of all, we are importing from two different places, from the AUT, which is the Abstract Window Toolkit, and you've seen that already in a couple of the homework assignments. The newer version of the Java graphical package that supports GUIs is the javax.swing library, which is built on the AUT library. So AUT is version 1.0, Swing is version 2.0, and is built on top of the AUT. Again, AUT stands for Abstract Window Toolkit. I forget what Swing stands for. And you can see we're also including a sub-package from the AUT called the event package, which deals with events. And from Swing, we're including a sub-package from borders, which is going to allow us to put some borders around our objects. So the unlike before, I could have easily put this in the constructor, but instead, Java folks like to have a function called create and show GUI. So instead, I named it create and show GUI. So JFrame is the object in Java that creates a window. So in this case, the first thing I'm doing is setting the decorated look and feel to be true, which says to use decorations with the window. So we have nice window decorations. Next, we actually create the JFrame and give it a title, Hello World Swing. So at the top, it will be called Hello World Swing. So actually, let's actually run it in the background. So you can see these things. I'll put this into the background. So you can see here, Hello World Swing is the title. So that's what I called it. So now in Java, I don't actually draw on a window, but instead I have what are called container objects. So in Java, what I have is a JFrame, and then it has a container object called a JPanel. And the JPanel can have as many components associated with it, which are called JComponents, as I want. So the way I display things is I add things to this. This is a container object, and I can add things to it. Those things are what are called JComponents, and JComponents can themselves be container objects. So the way I get that panel is with get content pane, and I downcast it to a JPanel because it turns out it doesn't come back as a JPanel, but that's what it is. So now I've gotten that pane and I can do stuff with it. Before I do that, I, in the JFrame, set the default close operation to be exit. So it says what I should do when I hit this red button. There's different options, such as I could simply iconify the window, or I could make the window be invisible and not iconify it. But in this case, I actually would exit the application. So that's what it's saying is the close operation. What happens when I push that red button is it should actually exit the application. So now I want to display the label Hello World. And the way I do that is I create something called a JLabel. And a JLabel displays text in a window. And I want that label to have a border. So that's coming out of the swingx.border. There is a class called Border Factory that creates different kind of borders. In this case, I want a bevel border, and I want it to be raised. So I set the border of label, and then I add the label to the content pane. I could have just said pane because I already got the pane here, so it probably would have been better to just say pane.addLabel. So that adds it. Now I'm creating some other labels, west, north, east, and south. And for each of them, I'm also setting their borders to be a bevel border that's raised. And I am adding them to the this content pane. But notice now, before I just said with Hello World, I just said add label. Here, I'm not only adding the label, but I'm saying where I want it placed. So in Java, you have what are called layout managers. So layout managers are algorithms, that lay out the components in a container. So in this case, there's going to be 5 labels, and I'm using what's called a border layout. So a border layout is one type of layout manager, and it's very simple. It divides the screen into 5 regions: a north region, a south region, a west region, an east region, and a so-called center region. That's where Hello World is getting placed. If you don't indicate to the layout manager where it should be placed, then it gets placed in the center object. So you can only display in effectively 5 components. If you try to add a second object to any of the regions, it overrides the first one. So you wouldn't see what the first one looked like. So here I'm adding 5 labels to 4 where I'm specifying west, north, east, and south. And then the label itself went into the center. I didn't specify which region, so it was defaulted into the center. Okay. Then I wanted to specify that when I click with the mouse, I want to toggle between Hello World and Bye World. So to do that, I can add what is called a mouse listener, and we will get to that. So don't worry, I'm just giving you an example now. And the mouse listener tells the Java interpreter that when a mouse event occurs on this particular panel, this content pane, then I want callback procedures called. So in this case, there's 5 possible events supported by a mouse listener: mouse clicked, mouse released, mouse press. So mouse press, you press down with the mouse. Mouse release, you release. A mouse click is what happens after a mouse has been clicked and then released. And there's a couple other events that escape me off the top of my head that are also associated with a mouse listener. So a mouse adapter, a mouse listener is an interface that defines those 5 methods. The mouse adapter says, okay, oftentimes you don't care about some of those events, which is true here. The only event we care about is a mouse clicked event. So the mouse adapter is a class implementing the mouse listener interface, and it provides empty method bodies for those 5 events. And now we are overriding the mouse clicked event. So when that occurs, I have a Boolean variable called hello. If you look at the top, I declared this Boolean variable called hello right there. And so if it's set to true, I set the text in the label to Bye World. If it's false, I set the text to Hello World. I invert the hello so that the next time it will toggle. This pane.validate says that I want to notify the layout manager that something has changed. And then repaint says that I want to queue a paint event. So I can't repaint directly. Instead, what I have to do is queue a paint event. and at the appropriate time, the paint event will fire and it will cause Java to repaint the window. So that defines my one behavior. So now frame.pack, the pack command invokes the layout manager's algorithm and tells it to lay out the objects in the window, and then set visible makes the frame visible so that it can be displayed. So actually, right now, if I were to compile this, get rid of this other one for a moment. So you see, I'm going to hit the red button, it's going to go away. You'll notice here that it's actually very tightly packed. It's not a 400 by 400 window. And that's because the pack command takes the natural size of each object. So west, hello world, and east, that's their natural size. And it makes the window only big enough to accommodate them at their natural size. So it may or may not be that I want it to be bigger. Here, I would like it to be bigger. So to do that, I can set the contents pane's preferred size to be a bigger one. So I would really want that content pane to have a width and height of 400. So again, I compile it. But now I get a window that's 400 by 400, and you'll notice the center got all of the extra space. And if I resize it, the center is what gets all of the extra space. The other regions are just displayed at their so-called natural size. So that's a decision the display manager also makes, which is how much screen space to give each of the components. Okay. And then finally, in main, you'll see that I have this rather verbose javax.swing.swingutilities.invoke-later new runnable void run, and it creates and shows GUI. We will get to this, so don't worry too much about it. All it's doing is saying we don't want this program to run immediately in main. Instead, we want to wait for main to terminate. And when main terminates, then the event dispatching thread starts, and that's when we want this function to actually execute. So what actually happens is main finishes executing, which is immediately because there's no other command, and then the thread dispatching thread spins up and this method gets executed. So basically what happens is we have main and then it exits, and then we transfer to the event dispatching thread, which boots up, and it runs this create and show GUI function. So that's just kind of a matter of bookkeeping, but it is how you should invoke all of your GUI functions in Java, is you should delay them until the main has finished executing. Okay, so I have shown you basically the outlines of how you create something in Java and make it run. And as I've already said, basically you have a presentation component. which displays objects, and you have a behavior component, which is how you respond to user interaction. And the presentation component can consist of what we call widgets or custom graphics. So what I used were widgets. I used a J label. And widgets are predefined pieces of graphics that do certain things. So they are predefined pieces of graphics with predefined behaviors. So menus, I'm sure you've used menus, radio buttons, checkboxes. Those are all examples of widgets, predefined pieces of graphics with predefined behaviors. By contrast, custom graphics are application dependent. So they depend on the application. So a circuit editor would have circuit pieces. A game application would have game pieces. A simulation would have objects corresponding to physical processes in the simulation. And you drew custom graphics in homework assignments 4 and 5 when you were drawing rectangles and ovals and lines. Those were custom graphics. So we say that widgets are application independent because they have the same look and feel regardless of what application you're running. And the custom graphics are custom made and hence are application dependent. Custom graphics, as you might imagine, take much longer to develop because you can't just create an instance of them and provide some properties, which is what you can do with widgets. With the custom graphics, you have to often combine a number of different shapes in order to get the presentation you want. And also with custom graphics, you're going to have to define the behavior component. So you'll have to write methods that indicate what should be done with mouse events or keyboard events. Whereas with widgets, they already have predefined behaviors, and therefore you don't have to provide methods that do it. So the behavior component, as you've seen, uses events or associates callback procedures with events which make the presentation component react to the event. And the last thing I want to talk about is feedback. So when an event happens, there's two types of feedback that you want to provide to the user, and this is called syntactic feedback and semantic feedback. Syntactic feedback occurs during the operation. And semantic feedback occurs when the operation completes. So in both cases, the feedback is meant to tell the user, hey, I hear you, this is what is happening. So here, whoops, I don't want that. And just a moment. Let's go to PowerPoint. It's going to be easier. Okay, so here's an example. This is syntactic feedback right here. So as I am drawing this out, it's giving me syntactic feedback about what is going to be selected. When I release, nothing got selected. Great. Let's do it again. Still nothing selected. Okay. Here is final feedback. See how you have some handles associated with this? This is semantic feedback. Now, when I click here, this right here is syntactic feedback. It's showing me what will happen when I'm done. And when I release, that is semantic feedback. You'll notice that the white background disappeared. And this is the final result. So syntactic feedback occurs during an operation and allows the user to see what is going on. Gives them some idea of what will happen when the operation is complete. Semantic feedback occurs when the operation completes and is the final feedback. It actually changes the presentation component in some way. And generally, semantic feedback will often be provided by a callback function. Okay, so with that, I am going to let you go. Before you go, I just want to say that for today's quiz, make sure that you go over my Java GUI overview, because I think I've covered just about everything, but I still want you to go over this Java GUI overview before you take the quiz. I did not check before class exactly what was in the quiz, and I'm pretty sure I got everything, but just to make sure, look at both this link here, this overview of GUIs and interfaces, and this Java GUI overview. Okay, with that, I will let you all go. Reminder, I have office hours in 15 minutes. If you have questions, feel free to hang around and ask them. I'll be here for a few minutes before I go to office hours. And otherwise, I will see you all on Thursday. So you are all free to go.